Learning objectives. At the end of this topic, you will be able to measure the chance of occurrence of a particular outcome in an experiment, define experimental or empirical probability, solve problems on probability. Introduction. In the previous classes, we've learnt about probability, where we performed experiments like tossing of coins, throwing of dice, etc., and observed their outcomes. Now we will learn to measure the chance of occurrence of a particular outcome in an experiment. Probability is defined as the likelihood of something occurring. Now let's perform the following activity. Toss a coin in the air 5 times and record the outcome for each toss in the table. For each toss, the following outcomes are recorded. The values are entered in the table and the probability for getting a head and the probability for getting a tail is calculated. Now repeat the activity by increasing the number of tosses to 10, 15, and 20 and record the outcomes. What do you find? Experimental probability. Experimental probability or empirical probability is an estimate that an event will happen based on how often the event occurs after performing an experiment in a large number of trials. Based on our outcomes of the activity, we find the experimental or empirical probability. Let n be the total number of trials. Therefore, experimental or empirical probability, that is, P of E, is number of trials in which the event happened by the total number of trials, that is, n. Let us consider an example problem. A coin is tossed 1,000 times with the following frequencies: head 475 and tail 525. Compute the probability for each event. Solution. Since the coin is tossed 1,000 times, the total number of trials is 1,000. Let H be the event of getting a head. Let T be the event of getting a tail. Therefore, probability of H is number of heads by total number of trials. That's equal to 475 by 1,000, which is equal to 0.475. Probability of T is number of tails by total number of trials. That is equal to 525 by 1,000, which is equal to 0.25. Adding both the probabilities, we get 1. So H and T are the only two possible outcomes of each trial. Now let us see a dice problem. A die is thrown 1,000 times with the frequencies for the outcomes 1, 2, 3, 4, 5, and 6, as given in the following table. Find the probability of getting each outcome. Solution. Let EI denote the event of getting the outcome I, where I is equal to 1, 2, 3, 4, 5, 6. Probability of the outcome 1 is that P of E1 is frequency of 1 by the total number of times the die is thrown. That is 150 by 1,000, which is equal to 0.15. Similarly, find P of E2, P of E3, P of E4, P of E5, and P of E6. Now adding all the probabilities, we get 1. Note that the probability of each event lies between 0 and 1. The sum of all the probabilities is 1. E1, E2, and so on up to E6 cover all the possible outcomes of a trial. Consider the following problem. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. The table shows the results of 1,000 cases. If you buy a tire of this company, what is the probability that it will need to be replaced before it has covered 4,000 kilometers? It will last more than 9,000 kilometers. It will need to be replaced after it has covered somewhere between 4,000 kilometers and 14,000 kilometers. Solution. The total number of trials is equal to 1,000. The frequency of a tire that needs to be replaced before it covers 4,000 kilometers is 20. So, P of tire to be replaced before it covers 4,000 kilometers is 30 by 1,000, which is equal to 0.03. The frequency of a tire that will last more than 9,000 kilometers is 320 plus 450 equals 770. So P of tire will last more than 9,000 kilometers is 770 by 1000, which is equal to 0.77. The frequency of a tire that requires replacement between 4,000 kilometers and 14,000 kilometers is 200 plus 320 equals 520. So P of tire requiring replacement between 4,000 kilometers and 14,000 kilometers is 520 by 1000, which is equal to 0.52. Let us consider another problem. 50 seeds were selected at random from each of the 5 bags of seeds and were kept under standardized conditions favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows. What is the probability of germination of more than 40 seeds in a bag? 49 seeds in a bag. More than 35 seeds in a bag. Solution. Total number of bags is equal to 5. Number of bags in which more than 40 seeds germinated out of 50 seeds is 3. P of germination of more than 40 seeds in a bag is 3 by 5, which is equal to 0.6. Number of bags in which 49 seeds germinated is equal to 0. P of germination of 49 seeds in a bag is 0 by 5, which is equal to 0. Number of bags in which more than 35 seeds germinated is equal to 5. So the required probability is 5 by 5, which is equal to 1. Remember, in all the problems explained above, you would have noted that the probability of an event can be any fraction from 0 to 1. Summary. Let's summarize the topic. The probability of an event is the measure of the chance that the event will occur as a result of an experiment. An event is a collection of some outcomes of the experiment. The experimental or empirical probability P of E of an event E is given by P of E is equal to number of trials in which E happened by total number of trials. The probability of an event lies between 0 and 1, 0 and 1 inclusive.